Today, we're going to talk about something really cool. A story where two complete failures, I mean total failures, came together to create one massive success. We're talking about UV-proofing plastic and a really amazing tale of synergy.
All right, let's start with something you've probably all seen. You know that brand new, super colorful plastic chair you bought for the patio? And then after just one summer, it looks, well, sad. Faded, brittle, maybe even cracking. What's going on there? Yeah, you guessed it, the sun.
But what if it didn't have to be that way? Well, get this. Scientists just found a way to make plastic tougher against the sun. We're not talking a little bit tougher, like 10% or even 100% better. No, we're talking over 100 times more resistant. And the craziest part? The secret was combining two methods that on their own were total duds.
Okay, so to really get how they pulled this off, we've got to understand the enemy here. Let's take a look at what the sun is actually doing to plastic, way down at the molecular level.
So sunlight, especially its UV rays, is just brutal. It kicks off this thing called photooxidation. That's just a sciencey way of saying it's a chemical assault on the plastic. It's like taking a tiny pair of scissors and just snipping apart the long chains that make plastic strong. This creates these nasty little things called free radicals. And boom, that's why your stuff gets brittle, cracks, and the color just fades away.
And look, this isn't just about your chair looking bad. This constant damage shortens the lifespan of everything. Think car parts, outdoor equipment, you name it. We have to replace stuff way more often, and all that junk just piles up, adding to the huge global problem of plastic waste.
All right, so the scientists knew the problem inside and out, and they had two, really high-tech, sophisticated ideas to solve it. But, and this is where the story gets good, neither one of them worked at all. The two big ideas were something called atomic layer deposition, or ALD for short, and vapor phase infiltration, VPI. Now, this is some serious next-level stuff. Think of ALD like the most precise paint job imaginable, building a shield literally one atom thick at a time. It's supposed to be this perfect, unbreakable barrier. VPI is a totally different approach. It's more like soaking the plastic in a super primer, letting these protective chemicals actually seep into the material. I mean, on paper, you'd think both of these would do something, right? So what went wrong? Well, fail is putting it mildly. They failed spectacularly. And this chart just shows you the whole puzzle. They blasted these plastics with intense UV light, and look at this. The plastic with just the ALD coating, 95% of it was just gone. And the VPI stuff, almost 90% destroyed. Turns out the ALD shield was too delicate and couldn't stick to the plastic. And that VPI primer, just not tough enough on its own. On their own, they were basically useless.
So what do you do with two failed experiments? Well, these researchers had a crazy idea. They thought, hey, what happens if we just stick them together? And what they found was a genuine breakthrough, all thanks to one really powerful idea. And that idea is synergy. You've probably heard the term. It's when you combine two things and the result is way bigger than just the sum of the parts. It's that classic 1 + 1 = 3 situation.
So here's how the new process works. First, they used VPI, but not as the main shield. They used it as a primer. Those chemicals seeped into the plastic and created these tiny little seeds all over. Then they came in with the ALD coating. And this time, instead of just sliding off, it had all those seeds to grab onto, and it built this incredibly dense, perfect protective shield.
Okay, this right here is the secret sauce. This is the key to the whole thing. Those seeds are technically called nucleation sites. See, the problem was that the ALD coating, as amazing as it is, had nothing to hold onto on the super smooth plastic. It was like trying to paint on a sheet of glass. The paint just won't stick. The VPI process, our first failure, totally solved this. It created millions of these tiny little anchor points for the ALD shield to lock onto. It turned into the perfect primer for the perfect paint job. And the result? It wasn't just a little better, it was staggering. With that VPI primer doing the prep work, the ALD shield grew over 10 times better than it did on the plain plastic. So you see, VPI wasn't the shield itself. It was the key that unlocked the incredible power of the ALD shield. Okay, so the theory sounds great, right? A primer and a top coat, it's elegant. But did it actually work in the real world? Let's take a look at the results, because they are pretty wild. So the big headline number here is just wow. The new combined coating made the plastic over 100 times more resistant to UV damage. Just let that sink in for a second. That's not 100% better. It's 100 times better. And this chart, I mean, it really tells the whole story. Just look at this. After being blasted by UV, the original plastic? Gone. The ones with just one coating? Pretty much destroyed. But then, look at that last bar. The one with the combo VPI plus ALD coating. Over 96% of it is still there. Totally fine. It is a complete night and day difference.
And hey, don't just take my word for it. The researchers themselves said the material exhibited excellent resistance, keeping over 96% of its thickness. It's incredible. What started as 2 total failures combined to create a nearly perfect shield. So how exactly does it pull this off? Well, this new coating basically acts like a super sponge for UV light. It just soaks up a stunning 94% of all that harmful radiation before it even has a chance to touch the plastic underneath. But here's the kicker, and this is really the best part. You get all of this amazing protection without a major trade-off. The coating is almost totally transparent, so you get this incredible UV shield, but the plastic doesn't get all dark or cloudy. It stays clear. And this is way more than just a cool science experiment. This really points to a future where we can actually build things to last. To really prove this would work in the real world, the team took a complex 3D printed object, this mesh, and they just hammered it with UV rays. We're talking the equivalent of 220 straight days of intense, nonstop sunlight. And the results were, well, you can see for yourself. It's just night and day. The regular, untreated mesh, it got so brittle that if you just touched it, it would shatter into a million pieces. But the one with the new coating, it was totally fine, completely intact, and, this is the important part, it was still flexible. It kept all its strength. So what's the big takeaway here? You know, this is about so much more than just saving your patio furniture. This is a real path toward making things that are just more durable, things that last longer. And that means less waste and a smarter, more sustainable way of making all this stuff we use every single day. Which kind of brings us to a final thought. This whole incredible breakthrough happened because someone decided to combine 2 ideas that were considered failures. It really makes you wonder, doesn't it? What other failed ideas are out there, just waiting for the right combination to completely change the world?